Good afternoon, everybody. So last class, we had seen about the functional block diagram. That is the basic layout, the features of 8051. And then we had progressed into understanding the pin configuration, the pin diagram details of Intel 8051 microcontroller. Yes, so today in continuation to it, we are going to understand the architecture of 8051 microcontroller. So first, when you touch upon this architecture, the first thing comes into picture is the oscillator. So this is your crystal oscillator. So all operations in the microcontroller are synchronized with help of this oscillator clock. Yes, oscillator clock is going to generate clock pulses by which all the internal operations are going to be synchronized. Okay, so now based on the oscillator clock pulses that is being generated, by this all the internal operations are synchronized. So now this is run with the help of a resonant network connected through the pins. We have seen the last class about the pin details which are relevant to your crystal oscillator. So you have connecting crystals 1 and 2 connected to the pins accordingly to form up the oscillator circuit. So for this purpose you use quartz crystal and a capacitor is being employed. So combination of this is going to act as a resonant network and this is going to form an oscillator. So the crystal run at a specified maximum and minimum frequency, which is typically between 1 megahertz to 16. And the oscillator clock in the oscillator circuit. So this is going to typically generate clock pulses. So with the help of these clock pulses only, the internal operations are going to be performed on a synchronized basis. Yes. Next, when I talk about microcontroller, first coming into picture is the ALU operation. So ALU. So this ALU is 8-bit unit. So this ALU is an, whatever you see here, is an 8-bit unit. Okay. So it performs arithmetic and it is going to perform arithmetic operations like your addition, subtraction, increment, decrement, and certain logical operations like your AND operation, OR operation, your XOR. All such arithmetic and logical operations will be performed in the arithmetic and the logic unit. So it manipulates 18-bit and 16-bit data. Okay. So when I talk about logical operations, you have to understand even it has also it can calculate the address of jumping locations in a relative branch instruction. Then it can perform comparison, rotate in the sense rotate left is the bits will be moved left and all such operations will come under the ALU. So all these operations will be carried out by the in the help of ALU. So 8051 microcontroller contains 34 general purpose register or working register. You can see you have temporary registers as well. So 2 of them are going to be dedicated math registers. So which is your A register or the accumulator register, and the other one is your B register, and you have 32 are bank of registers are available to perform this mathematical and logical operations. Yes, so we'll see the register organization in the later part. So we'll understand the architecture basically. So first, coming with the ALU. So ALU has got, if you understand, it performs the arithmetic and logic operations, and it has got in 8051. This ALU has this microcontroller has 34 general purpose register. So you have two of them. So your B register and A register. A register here is the accumulator. So, and this A register and B register are typically working towards or acting as your math registers, and the remaining are general purpose registers. So register is the where you store the values. So it is a location where you save. Okay. Next thing that we understand is we'll understand about the accumulator and this B register. So which are used for the mathematical registers. So first is accumulator. So this accumulator is again an 8-bit register. So its address will start from E0 and it is bit and byte accessible, in both ways. You can access bits and bytes. So it basically performs arithmetic and logical functions on 8-bit input variables, and that result of the arithmetic and logical operation performed, which the results, so this is going to perform the arithmetic and the logic operation, though the results of that ALU operation is being accumulated by the register. So hence it is called as accumulator. Result of the ALU operations that is being performed in this unit. So the result is holded in accumulator. Okay. So that is the purpose of your basic purpose of your accumulator. So it is used to store 8-bit data and to hold one of the operands. So it is used to store an 8-bit data as told, and it will sometimes hold one of the operands. So if you have A plus B, so one operand is A, so it can be held in the accumulator. So it will hold one of the operand of the ALU unit during the arithmetic and the logic operation. So most of the instructions are carried out on the accumulator's data only. So one of the operand will be here, the other operand will be in the register. So it will perform the ALU operation and the result is written back to the accumulator. So it is most versatile of the CPU register. Okay, it is the most versatile part that we are trying to utilize with respect to the CPU. So apart from storing the result, it has got accumulator is responsible for even conditional branching decisions, and it is going to provide, it has a provision to have temporary place for data transfer operations within the device. So you can see this temp1 and temp2 are going to be temporary places to store the data. Okay, that is with respect to your accumulator or the A register. Next is your B register. So B register is again a special 8-bit math register. So it is also bit by bit or byte accessible. So you can access individual bits or as a whole 8 bits at a time. That is your bit or byte accessible. So it is in conjunction with the A register. So as it can store one of the operands for the ALU. So it is again used for general purpose registers to store 8-bit data. So next is, so this is capable of doing even your apart from your mathematical operations, this is also, as told, apart from your accumulator, this B register is also going with the mathematical operation, and typically it is used in cases of multiplication and division operation because you can access the 8 bits directly. So it is very helpful in the place of multiplication division operation. So during the execution, so B register either keeps one of the 2 inputs or it is going to hold the portion of the result. So for the other instruction, it is used as, apart from your division and multiplication, for other purpose operations, you can use this B register for as a general purpose register to store an 8-bit data. Okay, so that is the functionality of an accumulator and a B register. So next is your when you see next is next thing that is very this program status word. Yes, program status word. So we've already understood about program status word, but we'll try to recollect and get into detail. So this program status word, so you need not worry. All the things that I'm explaining you, I have put it in the slides for you. Okay, it is all available as slides. Just try to understand this architecture. So if you understand 8051, you will be able to understand any other processor or microcontroller. So first, very relatively associated to your arithmetic and logic unit is the so it is this program status word will keep the current status of the arithmetic and the logic operation of different bits. Okay, so it is going to show you the current status of the arithmetic and the logic operation. So when you understand about it, it is happening with the program status is being shown in form of flags. Okay, so there are 4 conditional flags or mathematical flags which can be set and reset according to the condition of the results that is being arrived in the ALU. Okay, so you perform some arithmetic and logic operation. Based on that, you have certain status being changed. So that current status will be updated as flags in the program status word. So it has got 3 control flag by setting and resetting a required operation of the function. So we'll understand the flag format. So typically I told you it has got 4 mathematical flags that responds automatically based on the output of your or the outcome of your arithmetic logic operation, and it has got 3 general purpose user flags that can be set or reset. That is the point that you have to understand. So that 3 general purpose flags can be set or reset by the programmer. Okay, as desired, that you can do. So we have access, or as a programmer, we have access for 3 general purpose user flags, and apart from it, you have got 4 math flags, which is based on the outcome of the ALU operation. Okay, now we'll understand what is the flags. So first, when I talk about flags, so maybe I'll keep this and help you with this and understand. So flags. So when I talk about flags, so I have the format like carry flag, auxiliary carry flag, overflow flag, and parity flag. Yes, these are the math flags that are output of the arithmetic and the logic circuit. Okay, based on the operation that is being carried out in your ALU unit, you will have the flags being set or reset as an outcome automatically. Yes, so during addition or subtraction, we have the process of carrying and borrow. Yes, if you perform addition of two 8 bits, 8 bits data, then you will have possibilities of of coming to a point of carry or borrow that is being generated. So if you are if there is a point of carry or borrow being performed, then your corresponding flag is set. Otherwise, set in the sense it becomes 1. So carry flag will turn 1 automatically if you are going for the operation of carry or borrow. Otherwise, it is 0. Okay, so it is used in the case of when you are working on arithmetic So it will be set or reset when you are working on arithmetic, logic, jump instruction, rotate instruction, Boolean operation. So in certain these cases, your carry flag status may change based on the operations you perform. Right? So next is your auxiliary carry. So auxiliary carry is that. So what happens in auxiliary carry is that if during an addition or subtraction, any carry or borrow is being generated and that is carry is generated from the lower 4-bit to the higher 4-bit. So in that case, your AC, auxiliary carry is being set. Otherwise, it is reset. So when you go for binary coded decimal, so that operation, then you come across this arithmetic and logic. When you come across this, the auxiliary carry being set. So this is the perform based on the performance in the arithmetic logic units, like when you're doing binary coded decimal operation, then your auxiliary carry is being set. Yes. So certain based on certain operations only your the carry bits of your auxiliary carry flag is set or reset. So certain cases, certain cases like when you go for signed arithmetic operations. So say for instance, there become basically you will have 7 bits of data, 0 to 7 bits. So if upon addition or multiplication, you have an extra bit coming up. So say for instance, if your last bit, most significant bit is 1 and 1. Okay, addition of 1 and 1 will give 10. When you're talking in hexadecimal, one that is called to be the that will be arrived as a result. So that signed arithmetic operation is the point that we are talking about. So when that extra bit is generated, then what happens is that your overflow flag will be set. Otherwise, it is not set. If your two most significant bits of operand A and B is 1 and 1, then you have and 1 is will be the signed value, so it will be an overflow flag will be set. So next is parity flag. So this parity flag is an it will result. So when there is even number of ones, so when you are performing certain XOR operation, we go for parity check. So this is happening in that case. When this flag becomes useful when you are going for some XOR operation or certain kind of operations, this parity flag will account has its credibility. Parity. So parity flag is set. So if the result is odd number of ones, then your parity flag is reset. So if you have, say, if we are talking all in terms of ones and zeros only, all the values are binary values, 1 and zeros. So if in an 8-bit data, if you are counting, if you have even number of ones in the, then in the even number of 1 in a given 8 bits data, then your parity flag is set. Otherwise, your apart from the we have seen apart from the 4 mathematical flags, we have also have control flags that are going to be user defined. So we have 3 control flags. So F0, RS1 and RS0, which is going to which are user defined. Through programs we can define. Okay, so this is an user flags. So user can set and clear through a software program that we write. Yes. So next is your RS1 and RS0. So RS1 and RS0 is again, this is user set in the sense the user can select between the register bank. We told we have got 34 register banks. So 2 are like accumulator, 2 is accumulator. For general purpose registers. So in order to select those 32 register banks, we have the options through RS1 and RS0 to select which bank of registers that we want to use. The operator is going to select, or the programmer is going to select. So these are the control flags which the user can select through. So next, what is associated is your program counter. Yes, whatever you see here is the program counter and the program incrementer. So that is very closely associated with your ALU operation. Yes. So program. So if you see, program counter is a 2-byte address which is going to tell the processor 51 microcontroller that what is the next instruction to execute that is found in the memory. Yes. So your program counter is responsible. So it is a 16-bit, that is what it is, a 16-bit register giving address of the next instruction to be executed to the program memory space. Okay. So it is always, it is holding 16-bit of data of your internal RAM or external RAM or external ROM locations. So based on the program memory space, it is going to point to the address of what is the next instruction to be fetched and decoded. Yes, in that sense. So when the 8051 is initialized, your program counter will start during the execution process. Okay, so you have, for that purpose, you have the program incrementer. Is note that it is always incremented by, it is not always incremented by 1, and it is, you have to understand, your program counter is keeps incrementing based on the microcontroller that we are using and the program instruction word length. Based on it, we understood like in the previous microprocessor architecture, we were incrementing the program counter with a 4-bit value. Either to increment by 1 or by 2 or by 4 bits or 8 bits. That depends upon the architecture and the processor that we are trying to use. And it is never decremented. That is one point that we have to understand. So this is your program counter and the incrementer. So next you have the data pointer. So this data pointer, so the DPTR. So this data pointer is going to, it is again a 16-bit address register that can be used to fetch any 8-bit data from the data memory space. Okay, so this is, it is a 16-bit register. It is going to hold the address of the external or the internal RAM where the data is stored or the result is to be stored. So that is that value, it will be held in the data pointer register. So it is used to store 16-bit data. Okay. For 16-bit data, it can also be divided into 2 8-bit register. So it is a 16-bit register basically, but it has the flexibility that it can be divided into 2 8-bit registers. Say for instance, it can be data pointer higher order and data pointer lower order. So data pointer higher order will hold the 8 most significant bits, and data pointer lower order will hold the least significant 8 bits. So upper part and the lower. 16-bit data, store 16-bit data, or it can be divided as two 8-bit registers to hold your data pointer higher order and data pointer lower order. So each register can be used also as a general purpose registers to store 8-bit data and can also be used as memory location. So that is the functionality of this data point register. So we have understood about the program counter, then your data pointer. Next is the stack pointer. So we have stack pointer. So the stack pointer is again 8-bit register. So it is byte addressable. So by what is a stack pointer? Stack pointer is keeping the track of the memory space where the important it is holding wherein your important register information is stored when you are executing some subroutines. Okay, say for instance you are listening to my lecture. Okay, but then you have a call which is of more priority. So whatever you do is what that the phone call that you have received during the lecture class will be an interrupt. Okay, if the interrupt is of higher priority, you will address the interrupt. Yes, you will attend the call and you will resume back to listen the lecture. Yes, if it is of higher priority. If it is of some useless call, you will not attend. You interrupt. So what happens is that you attend the call and you come back and you continue listening. So similarly, there will be certain interrupts when you are executing the program. So certain subroutines will be called, or certain interrupts like say for instance serial communication device may ask you to enter a value. So there will be or your CPU may address it or not. In case if it is going to address that subroutine or certain interrupts, it has to store the last value that it was working with. So that is stored in the stack pointer. So upon storing in the stack pointer, it will go address the interrupt or the go execute the subroutine, and it will retrieve back from the stack pointer from the previous function where it was, or the previous instruction where it was there in the main program, and it will start continuing the process in the main program. So you understand that is the functionality of stack pointer. So it is used to hold the internal RAM memory location address, which is used as stack memory. So when the data is to be placed in the stack, that is when you are going to execute a subroutine, your main program will be placed in the stack. So the placing in the stack is called as push operation, and the content is being placed, and the value will be incremented by 1. So when you're trying to retrieve back the value, then the operation of retrieving the data from your stack is called as popping. So you will perform pop operation, and you retrieve the content from the stack pointer, and you will be. So always you have to remember that your stack pointer will be pointing to the top of the stack. So you would have understood the stack operation in your data structures. If you have understood the operation of the stack queue, all you would have studied there. So as a continuation, you are utilizing that stack as a register to hold, or memory location to hold the address of values. Okay. That is with respect to your purpose and the functionality of stack pointer. Then you have certain special function registers. So you have registers for timer and the counter operation. Then you have got registers that is for serial data. Then you have registers related to input and the output ports. You have special function register for your interrupts, all that. So one by one we'll see. So first is with respect to your timer and the counter. So, so timer and counter register is kind of special function register. Okay. So there are around 11 special function register that are grouped in certain way. Okay. So first group is going to be the timer bar counter register. So this timer bar counter register in 8051 has got two 16-bit counter or timer register, and it is referred to as T0 and T1. So we have already seen that register in the pin diagram itself. So we have seen it. So with the so this with the help of T0 and T1 registers, you can register. You can go for operations like, and you can split up your register into each register of 16-bit register to divide into lower and higher bit register. That is also possible, or you can hold the initial number of count. Typically, the entire register can be used to hold the number of count. So all the 4 registers are byte addressable. So I told you these are going to be the special function registers. So this it has got timer control register. So under this timer control register, what happens is it has got 2 8-bit timer control register. So this is to be T mod and T con register. So that we'll understand in a later lecture in detail. So we'll just understand that your 8051 has got two 16-bit timer or it is capable of operating in different modes. So in elaborate, what are the modes of operation, how it is working as a timer or control circuit, that we will detailedly discussed in your timer and control register part. So in the basic architecture, just you have to understand that it is capable of working in different modes. So, and it can each byte and lower byte, okay, which can be accessed via the software programming. So there is, as I told, with respect to your timer and your counter, we have got T mod and T con. So this is your, so your T mod and T con. Okay, so these are going to determine the mode of operation and the control registers. So basically, that is the functionality to configure the timers and the counters in lot number of ways. Yes. So what are the ways of and the modes of operation of the timer and control register? We'll understand. So basically, so these timers are used to measure time intervals. Okay. We can determine the pulse width or initiate an event, a trigger pulse. So all this are the applications of this timer and the counter units. So within, and if you look into the accuracy, it is going to work on like in the range of 1 microsecond resolution up to 65 millisecond. So that is the variation that you have got. And that is all possible via the software programming. Okay. So your T-con and T-mode are the registers related to your timer and counter. So next you have, apart from the timer and the counter, you have, next is your serial data transfer register. So it has got two serial data transfer register, your serial buffer register and your serial control register. Okay. So this already we have seen that your serial port is of high speed full duplex serial port. Okay. So your data transfer is full duplex. Okay, and this serial port has got two registers. So for data transfer, and SCON. So it is again an 8-bit register. it is byte addressable. As whole 8 bits only you can send. Okay, its address is 99. It starts from 89. So we have not looked into the memory organization. Once you understand the memory organization, we'll understand from what various your SBUF starts, various SCON register starts. So that register organization we have to understand. Okay, so based on that, in 8051 it starts with 99 and your serial control register starts with addresses 98. So both the registers your serial buffer register is going to hold data which is to be transferred serially. So this serial buffer register is typically used for serial data transfer. So this is going to hold the data which is to be transferred serially. Next, you have serial control register. It is the serial buffer register is byte addressable. That is, you can use it as 8-bit register only. But wherein your serial control register is byte or bit addressable. You can access each bit in that register or you can access as a whole 8-bit data. Okay, so both are possible in case of serial. So what is the purpose of is that the 8-bit loaded into this register controls the operation of the serial communication. So okay, that so in detail we'll also see about SCON when you are talking about serial data transfer with respect to your 8051 microcontroller. So we have the status pin for each, so that we'll understand when you're working when you are in the lecture on serial data transfer. Okay, next is your interrupt. So your 8051 typically we talk about, it has got two 8-bit interrupt register. Okay, one is IE, other one is the IP. So first one, IE is nothing but interrupt enable register. So your IP is interrupt priority register. So I told you based on the priority only you are going to address the interrupts. Okay, you have to work on the interrupts. Otherwise, you need not. So first is interrupt enable register. So again, this is an 8-bit register which is going to be bit or byte addressable. It is used to enable or disable function of an interrupt. Basic, as simple as that. So you and your interrupt priority register, it is again byte or bit addressable, and it is used to select low or high level priority based on each interrupts. Okay, so when I talk about interrupts, you can understand that we have different interrupt sources. As I told, you can have interrupts from your serial port when transmission and reception of data. You can have your interrupts when you have timer operation, when you overflow occurs, or there is some when you have internal interrupts. So interrupts may be dependent. It can be enabled or disabled. There are a lot of ways, but it can be selected based on the priority with the help of this registers. That is your interrupt enable register and interrupt priority register. Yes. Next is your excuse me. Next is your PCON. So it is going to be the power control register. So this power control register is again 8-bit register. So its bits are used to control mode operation. So whether you can work on an ideal mode or you can power down mode. So that kind of power saving mode operation, all is possible. So it is used to change even the baud rate of the serial communication. So that is the purpose of this power control register, PCON. Okay. (8051). So apart from the special function registers, you have something called as memories. So that you can see over here, memories. So this memory is when you talk about, you have internal RAM and you have internal ROM. Yes. So when we talk about memory, you have internal RAM and internal ROM. So your random access memory and your read-only memory. So when I talk about internal RAM, it is internal RAM of this 8051 microcontroller is 128 byte. Okay. Further internal RAM design we can see in detail when you are talking about the memory organization. So this internal RAM is identified into or organized into three distinct areas. So one area is for working registers, which 32 byte working registers or general purpose register, already which we have seen, the 32 general purpose registers. So that comes under the internal RAM category. Next you have to address from 00 to 1F. So this is going to be 16 bytes bit addressable. So it is going to occupy this memory space address from 20 to 2F. So all put together you have general purpose registers again from 30 to 7F. So all these becomes to be the 128. So we have three distinct areas to work on. Okay. So next is your internal. So your internal RAM, if you talk about, so it has got separate locations for your data memory and your program code memory. So both are difficult, are like in microprocessor we have seen data and program in the same memory in your von Neumann architecture. With respect to this, we have separate data memory and program code memory. Both are in different physical memory, but both have the same addresses that we have to understand. So internal ROM occupied is from 0000 to 0FFFF. Okay, so your program code or your program counter address the program from 000 only, and the higher order higher version of this is 0FFF. So that if that exceeds the internal ROM capacity, this will it will have problems with fetching the codes from the byte. So you should be understanding when you're talking about 8051, when you're writing the codes, you have to understand what is the specified RAM and the ROM allocations by looking into the internal RAM and the ROM. So with respect to your data, internal data memory, you have something like special function registers. You have upper 128 bits and the lower 128 bits being allocated by the internal RAM. So and your special function registers are also coming under this category only. They will also have this program memory there only. This 128 layout only. So this is the memory organization about your 8051 microcontroller. So we have understood about the pin diagram and the respective functionalities of each pin, and with the earlier to it we have seen the features and the functional block diagram. So based on the functional block diagram, we have advanced towards getting in details about your pin diagram, and we have progressed with microcontrollers architecture. So we are in the point, when you understand, we are in the functional block diagram, we have understood the pin diagram, we have understood what is the architecture. So once architecture is not there, but once you understand the microcontroller architecture, then you have a critical idea of what you are working, what you are trying to work on. So now in the forthcoming class, we'll understand about the instruction format and the addressing modes. Okay. So this is the next point of address that we'll talk about. And when you're knowing what is your architecture and your instruction format and the addressing modes, you will be able to write your own programs. Okay, so for the time being, since we do not have your offline mode of contact, so we'll try to run the programs in the virtual online platforms, so that you have certain flavor of execution of the program. So that we'll do. Okay, so apart from it, we'll understand how to interface with the timer or the IO ports, the serial communication. So all that we'll get into detail with respect to 8051 microcontroller. Yes. So any doubts so far? Clear? Yes. Is it clear for everybody? Okay. Good.